welcome to our second session of this workshop. Now we welcome Federico Picinali from the London School of Economics, who will give a talk entitled "In Defense of Intermediate Criminal Verdicts."
Thank you very much. In fact, I slightly changed the title. I added justice in between at the start. So I'm going to move around a little bit. Thanks so much, Jordi, for inviting me, first of all. I'm not really used to holding two things at the same time, but I'll do my best. So this presentation is part of a broader project on which I'm currently writing a monograph. And I say this for two reasons. Because, first of all, I have written some tentative chapters of this monograph already. So if you're interested, I'd be very happy to send them to you. And the second and more important reason is that, given that this is a work in progress, I very much value your feedback. Feedback to this presentation and feedbacks to the chapter if you want to read them. Okay? So thanks so much. So this project is about a comparison between what I call the binary model of the verdict system and the many-valued model of the verdict system. Now, the binary model can be easily visualized with this diagram. The horizontal axis measures the probability of guilt as a number going from 0 to 1. As you can see, there is one standard of proof. If the standard of proof is met, the verdict is guilty and punishment follows. If the standard of proof is not met, the verdict is not guilty and no punishment follows. Now, this is the system that is most common in Western jurisdictions, for instance, England and Wales. The many-valued model of the verdict system instead can be characterized as including a ladder of at least two standards of proof, accompanied by a ladder of verdicts, with an additional verdict that is referred for the case in which the lowest standard of proof is not met. And each verdict may be accompanied by a sanction, in which case the severity of the sanction increases with the probability of guilt that corresponds to each verdict. Now, there could be infinite instantiations of this many-valued model, because there could be infinite arrangements of standards of proof, verdicts, and sanctions. But the one instantiation that I focus on is possibly the simplest example of many-valued model and can be represented with this diagram. Can you see it? Because the table may be in the way. So as you can see, there are reasons why I focus on these instantiations, and I'm not going to talk about these reasons now, but if you want, we can go over this during the Q&A. As you can see, this many-valued model retains the two courses of actions or options that are available under the binary model, so guilty without punishment and guilty with punishment, but it also includes an intermediate verdict or an intermediate course of action between the two, okay? And of course, instead of having one standard of proof, it will have two standards of proof. Now, what I aim to show in my research project is that this particular many-valued system is superior to the binary system. But I want to premise what I'm going to say in the rest of the presentation with a proviso. That even if I failed in showing that the many-valued system is indeed superior, I think my research project would still be valuable. And this is because the question as to why we currently have a binary system is theoretically underdeveloped. I suspect that most of you have an intuition that the binary system is the right one to have. But this intuition is very rarely unpacked in the literature, and I contend that it's much harder to unpack this intuition than someone may think at first sight. So if at the end of the project I fail in showing that the many-valued model is superior, at least I will have contributed to unearthing the reasons as to why we have the model that we currently have. Having said this, I would like to spend a bit of time giving an overview of the project, after which I will focus on one specific question that is part of the project. And of course, your questions are welcome on whatever part of the project they are, okay? Even on parts that I'm not going to discuss at much length today. There are only a handful of recent works on the comparison, okay? It's a handful, probably 4 or 5. However, if someone studies this question, it's very interesting to discover that the debate on this comparison is centuries old. And in fact, it's a debate that has accompanied real experiences of many valued systems that one can find in legal history. So what I want to do in the first part of the project is precisely to try to unearth and engage with this debate. And in particular, to try to show that the arguments that have been produced in this historical debate against the many-valued model are not valid or not sound, okay? So the experiences that I'm going to look at are obviously Scotland, which has come up multiple times already in this workshop. So as you know, either from previous knowledge or from the previous presentation from Diego, Scotland has 3 verdicts. There's a not proven verdict in between the guilty and not guilty verdict. Now, someone earlier was talking about, or wondering about the historical reasons for this. Apparently, it was a historical accident. I'm not going to say more about this, but if you want to hear more about it, we can talk about it later, okay? So, in the 30 years or so, the not proven verdict has come under the attack of politicians, academics, and the public more generally, especially as a result of some high-profile cases involving heinous crimes and ending with a not proven verdict, okay? Some of the arguments that have been made are that it's not clear what not proven means, it's not clear what is the standard of proof that discriminates between not guilty and not proven stigmatizes the person who receives it, and another argument that is being made is that not proven makes it harder to obtain a conviction. And this last argument, by the way, is corroborated by the empirical research that I mentioned earlier. Notwithstanding all these attacks, not proven has resisted, so it's very much part of the Scottish verdict system nowadays. The second experience I would like to talk about is the jus commune trial, in other words, the criminal trial that existed in continental Europe in the late Middle Ages up to the early modern era. As probably all of you know, that trial was characterized by a golden rule, the rule saying that you cannot convict unless there's either a confession or 2 coherent testimonies. Now, there's a bit of debate amongst historians about the origins of the rule, why did this rule exist in the first place, and also whether this rule was a sufficient or a necessary condition for conviction. I'm not going to talk about it, but certainly all agree on the fact that it was perceived as a stricture. So in fact, it made conviction harder to achieve. And therefore, some ways around this stricture were found, and the obvious and most famous way is the use of torture in order to extort a confession. But the other way that I want to talk about is allowing for a lesser kind of conviction in the case in which full proof, i.e. confession or 2 coherent testimonies, was not available, but only something that was referred to as half proof was available. And this could be circumstantial evidence or a combination between testimony and circumstantial evidence. Now, if only half proof was available, then the judge was allowed to convict to what was referred to as pena extraordinaria, so extraordinary punishment. In other words, it wasn't the ordinary punishment that invariably was execution, but it was something short of execution. So the workhouse, the galley, transportation, or some corporal punishment short of death. So you can see that many valued dynamics in place here. Lesser evidence, lesser punishment. And importantly, another type of intermediate option that was available was what was called the absolutio ab instantia, which basically means that the trial was effectively put on hold with the possibility of reopening the trial if new evidence was coming up. Okay? So this again is an intermediate option between not guilty and guilty. The third option that I am going to study is that of Italy, very briefly. Up until the reform of 1999, from the start of the 20th century roughly, Italy had a third verdict, which was called sentenza dubitativa or assoluzione per insufficienza di prove. And this sounds very much like the not proven of Scotland, But there's a crucial difference here. And here I go back to what Barbara was alluding to earlier. A soluzione per insufficienza di prove had some legal effects that not proven doesn't have. For instance, it was to be included in the criminal record of the defendant. It could be taken into account for sentence enhancements in future trials or for assessments of dangerousness, okay? So it was definitely a more serious intermediate measure than the not proven verdict. Now, as I said, my interest is in trying to engage with the debates accompany these experiences. Just to give you a taste of some of the arguments that have been made against the many-valued model in these debates. Some have said, for instance, that the many-valued model is not compatible with an adversarial system because intermediate verdicts do not clearly signal which party won the case. Some have said that the intermediate verdict offers a cop-out to the adjudicator, in other words, a way of avoiding responsibility. Some have said that the intermediate verdict tarnishes the public faith in the accuracy of the criminal trial, because the intermediate verdict is inevitably probabilistic in the lay sense that it makes it clear that there is a doubt about whether the person is guilty or not, whereas the other verdicts are categorical. You're either guilty or not guilty. And then there's a quite strong argument, which is the argument that the many-valued model is not compatible with the presumption of innocence. And this is, I think, a particularly powerful argument, and because of this reason, I think it deserves greater consideration than the others, and in fact, I address this argument in a separate part of the project, which I call the justification of the many-valued model. Now, obviously, if I succeed in showing that the arguments against the many-valued model presented in the historical debates are unsound, I already have offered a pro tanto justification of that model. But I think that for a full justification, two further questions need to be addressed. And the first one is whether the model is compatible with all essential principles of criminal justice. In other words, all those principles such that if we were to relinquish them, we couldn't see ourselves as doing criminal justice. And my focus specifically is going to be on the presumption of innocence. So the argument for the incompatibility between the presumption and the many-valued model goes roughly like this. People have said, especially within the Scottish and the Italian debate, that if we construe the presumption of innocence as including not just a rule on the allocation of the burden of proof, but also a rule of conduct, in particular a rule saying that criminal justice authorities should treat the defendant as innocent until this person is proven guilty. Well, if we interpret it in this way, then these people say it is inevitably incompatible with intermediate verdicts, because intermediate verdicts are issued against individuals who are not guilty, okay, not legally guilty, and certainly they're not compatible with treating them as innocent, especially if they are accompanied by a sanction, okay? So this is the argument. I think the argument is wrong, but I'm not going to give you my counter-argument now. If you want, we can come back to this during the Q&A. There's a second crucial question in the justification of the many-valued model. Someone could say, well, maybe you managed to show that the many-valued model is compatible with all essential principles of criminal justice, but we could say the same of the binary model. So then we need a tiebreaker between the two, right? And I think this question provides a tiebreaker. And the question is whether the model is superior to the binary model according to a salient criterion, okay? And in the rest of the presentation, I'm going to focus on this question exclusively, okay? So I'll come back to this in a moment. The last part of the project is one where I argue that all theories of punishment should concern themselves with the choice between the binary and the many-valued model. More specifically, they should concern themselves with what I call the problem of empirical uncertainty, which is the problem of determining how the uncertainty with respect to the responsibility of the defendant should affect the agency of the state qua criminal adjudicator, okay? And this problem, of course, includes the selection of the standard of proof, but more broadly, the selection of the verdict system, okay? So the very question that my project is about. I say that all theories of punishment should concern themselves with this question because theories of punishment are ultimately theories of action, and therefore, in my view, they should not disregard one of the crucial variables of human decision making, which is the uncertainty with respect to the relevant state of affairs, in particular the responsibility of the person affected by punishment or by an acquittal, okay, the defendant. So my goal in this last part of the project is that of showing that under both consequentialist and deontological theories of punishment, the many-valued model offers a superior way of dealing with the problem of empirical uncertainty. There's a last slide in the presentation that is about this. If I have time, I would like to go through the main points there, because I'm particularly interested in that. If I don't have time, I'll have to leave it out, but hopefully we'll manage to talk about it in a different setting. So, okay, now, as I said, I'm going to focus specifically on the question whether the many-valued model is superior to the binary according to a salient criterion. This is one of the questions that has been addressed in one of the papers I've written already. So there's a caveat. The argument that I'm going to present is a little bit abstract, and I apologize for this, but I think this abstractness is necessary to reach my conclusion. However, I hope to keep you awake and interested, and I promise you that later I'll try to give you a concrete example of the implications of this abstract argument. But the second thing I wanted to say is, again, if you want to look at the argument in more detail, I'd be very happy to share the paper with you. Inevitably, the argument as it is presented here is a bit of a sketch, and some of the graphs I'm going to rely upon are a bit imprecise. But the more precise material is in the paper, again, so if you want it, I'd be very happy to send it with you, and I'd be very grateful for any comment. So, obviously, the first question is, what is the salient criterion? And I think that an obvious answer to this question is that the criterion should be the value that each model or system produces. And in saying this, I'm of course comforted by the fact that Loudon cares about it, and is one of many, right? So the focus there is on the value or aggregate value that each system produces, okay? Of course, Loudon talks about it with respect to the binary system, even though he's one of the few people that actually wrote about this comparison. So, according to this criterion, the system that is superior is the one that produces higher aggregate value. How do we calculate the aggregate value? We just calculate the distribution of outcomes that each system produces or would produce if implemented, and then we assess what is the value of this distribution, and then we compare the two values. So for a binary system, we'll have to look at how many false acquittals, true acquittals, false convictions, true convictions are produced by the system. In the case of the many-valued system, we'll have to look at also at intermediate outcomes. So how many cases in which the intermediate verdict is adopted when the defendant is innocent, and how many cases in which it is adopted when the defendant is guilty. Now, the obvious problem with this criterion, and I think this surfaced very well in the excellent presentation from Diego earlier, is that at the current state of our cognitive capabilities, we're not really able to produce a reliable and comprehensive picture of the distribution of outcome that the current binary system produces, be it the Spanish, the Italian, the American. So, a fortiori, we are unable to produce a coherent and comprehensive and reliable picture of what a many-valued system would produce if it were implemented, okay? So I think the problem with this particular criterion is epistemological, all right? So I suggest that we use a different criterion, which is expected value. And as I aim to show in this presentation, in order to compare the two models with respect to this criterion, there is no need to calculate any distribution of outcomes. It's sufficient to rely on the design of each model. In other words, on questions such as where do the standards of proof lie, what are the options that are available in these models. In fact, the essential feature of the design that is sufficient for this comparison is the structure of the value function that is premised in each model, okay? I say this here, maybe it's not easy to make sense of it now, but in the paper I try to explain this point a bit more carefully. I just wanted to say it to be more complete and precise. So the skeleton of my argument is, the setting criterion is the maximization of expected value. Under a certain condition, which I call the superiority condition, the many-valued model maximizes expected value. Therefore, the many-valued model is superior if this condition is met. Okay? I have to say from the start that the superiority condition pertains to the features of the intermediate course of action. Okay? It's something that tells us something valuable about the nature of the intermediate course of action. All right? This will become a bit clearer later during the presentation. So again, I apologize in advance for the abstractness of the next few slides. Then we'll come back to concrete examples later, if you bear with me. So the starting point of my argument is a well-known argument in evidence law theory, and it is the decision theoretic argument for the selection of a standard of proof in a binary system. Okay? I'm going to try to explain this argument as carefully as I can and keep things as simple as possible, although I'm aware that in the room there are people that know much more about decision theory than I do and are much more mathematically literate than I am, so I'm a bit wary of saying wrong things. Anyway, so for those of you who are not familiar with decision theory is premised by the principle that we should act so as to maximize expected value. Okay? So we should choose the action that maximizes expected value. So the crucial calculation there is that of the expected value of each of the courses of actions that are available. Okay? So how do we calculate the expected value of an action? We look at the possible outcomes of this action, calculate the expected value of these outcomes, sum up this different expected value, and then we get the overall expected value of the action. I'll give you an example. Think about the binary system. We have two possible actions, acquittal and conviction. Let's focus on acquittal first. We have to identify first the possible outcomes of an acquittal. You can acquit the innocent or acquit the guilty. So let's calculate the expected value for each of them. The expected value of acquitting the innocent will be given by the value of acquitting the innocent and the probability that the defendant is innocent, which is 1 minus the probability the defendant is guilty, of course. The expected value of acquitting the guilty will be given by the value of acquitting the guilty and the probability the defendant is guilty. When we have these two expected values, we sum them up and we get the expected value of the overall action of acquitting. We do exactly the same for conviction, and then we have two values, that for acquitting and that for conviction. We assess which one is higher, and then we decide according to this assessment. Okay? We'll choose the course of action that maximizes expected. Right? So these are the basics. This is roughly as much as I know about decision theory. This is what is sufficient for you to understand what is coming next. Okay? Now, when I say value, of course, the relevant notion of value would depend on the theory of punishment that one endorses. Okay? I'm not going to say more about it, but I just wanted to make it clear. So I'm going to show now a graph which visualizes the argument for the selection of a standard of proof in a binary system. Okay? So on the horizontal line, we have the probability of guilt is a number going from 0 to 1. On the vertical line, we have the expected value. And there's two lines plotted on the graph. The red line, which expresses the expected value of convicting, and the blue line, which expresses the expected value of acquitting. Now, let's focus on the red line. As you can see, when the probability of guilt increases, the expected value of convicting increases, because if we convict, we are increasingly likely to convict a guilty person rather than an innocent person. And convicting a guilt is a welcome outcome. Look at the blue line now. As the probability of guilt increases, the expected value of acquitting decreases, because if we acquit, we are increasingly likely to be acquitting a guilty person rather than an innocent person. And the acquittal of the guilty is not a welcome outcome. Now, the two lines intersect at one point, which means that at that point, we are indifferent between acquittal and conviction because the expected value of the two is exactly the same. And decision theory says that the standard of proof should be set at the probability of guilt that corresponds to that point. And that's indicated by the P star at the bottom of the graph. Okay? As you can see, when the probability of guilt is higher than P star, we should convict because conviction yields higher expected value than acquittal. When the probability of guilt is lower than P star, we should acquit because acquittal yields higher expected value than conviction. Okay? So far, so good. Now, I would like you to focus on this broken line over here. So the line that includes this section of the line of acquittal up to the point of intersection, and this section of the line of conviction from the point of intersection to the end of the graph. Now, that's the strategy that the adjudicator should follow in a binary system. In other words, the adjudicator should acquit up to the point where the probability of guilt equals standard of proof, and above that point, it should convict. And this broken line, and this is important, sets the limits of the binary system in terms of the maximization of expected value. So the adjudicator, given the two options of acquittal and conviction, cannot, at any point of the probability of guilt, produce higher expected value than it is indicated by that line. Okay? And this is the reason why I call that broken line the ceiling of the binary system. So in this graph, I have colored the ceiling of the binary system in green so as to make it more visible, even though probably it's less visible given the light condition here. But anyway, my intention was good at least. So the next step of the argument for the superiority of the many-valued system is quite straightforward. If the criterion of superiority is the maximization of expected value, and if the ceiling of the binary system sets the limit of that system in terms of the maximization of expected value, then the many-valued system will be superior to the binary system if the ceiling of the many-valued system is geometrically higher on the graph than the ceiling of the binary system. Now, this is a little bit rough, but I'm trying to refine it with the following words. So remember what I said earlier. So the many-valued system that I'm focusing on is one that retains the two options that are available in the binary system, so acquittal and conviction, which means that the two lines plotted on the graph are valid also under the many-valued system. The only difference between the many-valued system that I focus on and the binary system is that the former also includes an intermediate course of action between acquittal and conviction. So if those two lines are valid under the many-valued system, it would be the case that for the ceiling of the many-valued system to be geometrically higher than the ceiling of the binary system, the intermediate course of action must be represented by a line that travels higher than the ceiling of the binary system at any point of the probability of guilt. Okay? Now, in the paper, I argue that the lowest point of the ceiling of any plausible binary system is the point corresponding to P star, is the point corresponding to the standard of proof. And this is, of course, true in this example, right? It's this point. So the next step is for the line corresponding to the intermediate course of action to be higher than the ceiling of the binary system at any point of the probability of guilt. This line will necessarily have to be higher than that ceiling at P star. I drop a footnote here. This is true only if that line corresponds to an intermediate course of action, which is indeed intermediate. And in the paper, I give a definition of what intermediacy means. If you want, we can come back to this later. But what I've given you now is nothing but what I call the superiority condition of the many-valued system. I'm going to restate it. For the many-valued system to be superior to the binary system, it has to incorporate an intermediate course of action that can be represented by a line which travels higher than the ceiling of the binary system at P star, the standard of proof. Okay? Now, the crucial question is, how do we identify a concrete example of such a course of action? Okay? Because so far we've been talking in the abstract, but it would be nice if we were able to identify a course of action that satisfies the condition. In order to do that, or in fact, I think I'm actually I'm skipping a slide. So, in this slide, I'm showing you what the line corresponding to the intermediate course of action should look like in order to warrant the superiority of the many-valued system. The line, of course, is the purple line. So this graph shows a many-valued system superimposed on a binary system. Okay? So as I said earlier, the green broken line is the ceiling of the binary system. Of course, the ceiling of the many-valued system is different because it also includes a section of the purple line. So the ceiling of the many-valued system includes this section of the line corresponding to acquittal up to the point of intersection between that line and the line corresponding to the intermediate course of action. Then it includes this section of the line corresponding to the intermediate course of action up to the second point of intersection with the ceiling of the binary system. And then finally it includes this section of the line corresponding to acquittal. So the strategy that the adjudicator should follow in a many-valued system would be to acquit up to this first point of intersection with the line corresponding to the intermediate course of action, and this would be our first standard of proof. Then apply the intermediate course of action, or take the intermediate course of action up to the second point of intersection. This is the second standard of proof, and then convict above this point. Just a drop a footnote, an interesting point here is that if all of this is accurate, then the standard of proof for conviction is actually higher in the many-valued system than it is in the binary system. I close this parenthesis. Why does that maximize expected value? Obviously because the ceiling of the many-valued system incorporates a section of the line corresponding to the intermediate course of action, which is geometrically higher than the ceiling of the binary system. All right. So then, as I said, the crucial question now is try to identify a concrete example of this intermediate course of action. And in order to do that, I think we need to delve a little bit deeper to the meaning of the superiority condition. Okay? Bear with me a little bit more for a bit more of abstractness, and then we'll come back to the concrete world. So in the paper, using the little mathematical knowledge that I have, I give a series of formal formulations of the superiority condition until I reach this formulation, okay? And this is the one that I finally work with, because I think it's the one that gives us most useful information on the nature that the intermediate course of action should have to warrant superiority. So in order to understand what this formula says, we can use this graph, which is nothing but another version of the previous graph, but it contains a bit of notation that was missing there. So let me introduce the notation very quickly. It's nothing new from concepts I've used so far, but this represents the value of acquitting the innocent. This is the value of convicting the innocent. This is the value of adopting the intermediate course of action towards the innocent. This is the value of convicting the guilty. This is the value of acquitting the guilty. And this is the value of adopting the intermediate course of action towards the guilty. Now, what this formula says is that the ratio between this interval and this interval should be greater than the ratio between this interval and this interval. So let's try to understand what this means. The superiority condition concerns the position that the value of adopting the intermediate course of action towards the innocent should have, within the interval between acquitting the innocent and convicting the innocent, relative to the position that the value of adopting the intermediate course of action towards the guilty has, within the interval between convicting the guilty and acquitting the guilty. Now, the inequality between ratios of differences that is expressed by this form can be made more intelligible if we express it as the requirement that within the interval between the value of acquitting and the value of convicting, the value of adopting the intermediate course of action towards the innocent should fall more towards the value of convicting when the defendant is guilty than when the defendant is innocent, okay? One way of making this requirement even more accessible is by saying that the intermediate course of action should be such that when it is imposed on the guilty, it resembles more closely a conviction than it does when it is imposed on the innocent. Or yet another way of expressing this, which is the verbalization that I prefer, is to say that the intermediate course of action should be such that when it is imposed on the guilty, it consists in a more severe measure than when it is imposed on the innocent. Okay? So this is the verbalization of the superiority condition that I prefer, and is the one that, in my view, allows us to identify concrete examples of intermediate courses of action that satisfy that condition. So let me give you an example of that. So here is our verbalization. I'm going to read it again. For a many-valued system to be superior to the corresponding binary system, the intermediate course of action employed by the former should be such that, when it is imposed on the guilty, it consists in a more severe measure than when it is imposed on the innocent. So, for us, the task now is to think of sanctions, courses of action, whatever, that would satisfy this condition. Because if they do, and if a system adopts intermediate courses of action, then according to this argument, assuming I'm right, I may not be, but that system will be superior to the binary system. Okay? Now, this problem, the problem of identifying an intermediate course of action that satisfies this condition, may strike someone as the quest for the philosopher's stone. Because considering how important it is for us to protect the innocent from conviction, well, it would be great if we managed to identify a course of action that consists in a more severe measure if we impose it on the guilty than if we impose it on the innocent. But is it really the quest for the philosopher's stone? In my view, it's not. Meaning I have 10.
10 or 15
or 20, but no, okay, I'm joking. No, because you were being very relaxed, 10 or 15, so I thought maybe I can push it a bit more. No, okay, 10, 15 should be definitely sufficient, and thank you guys for bearing with me. But so is it the quest of the philosopher's stone? No, I think it's not. And in the paper, so I think there's two different ways of going about answering this question, so trying to identify a concrete example. One way would be to argue that it's possible to identify an intermediate course of action that satisfies the condition as verbalized in all cases that would be adjudicated by the system. All cases. Which in other words means that the many-valued system would supersede the binary system across the board. In all cases. We just get rid of the binary system. But another tack would be to argue that we can identify intermediate courses of action that satisfy the condition only in cases of a particular kind, say cases involving certain crimes or defendants that are of a particular dangerousness. Okay? If this is the most that we can do, then the many-valued system would supersede the binary system in these cases, but the binary system would be operative in all the other cases. Now, in the paper, I follow this second tack, and I try to identify some intermediate courses of action that satisfy the condition in some cases, with specific features. But after writing the paper, I think I'm becoming increasingly confident that the first tack is right. So it's possible to actually identify one intermediate course of action that satisfies the condition across the board. And I'm going to tell you what I think this intermediate course of action is, but with the proviso that this is a working hypothesis, okay? I've been thinking about it, but probably not long enough. So you may think this is completely far-fetched. But in my view, an intermediate course of action that may satisfy the condition is something akin to the absolutio ab instantia, which I mentioned earlier when referring to the medieval criminal system. Which in other words means that the trial is effectively put on hold, but if new evidence of the defendant's responsibility emerges, the trial can be effectively restarted or reopened, okay? So this option would effectively deprive the verdict of the finality that normally characterizes verdict, in particular acquittals in common law systems, okay? So why do I say that this option would satisfy that condition? Again, working hypothesis, but because my view is that if the defendant is guilty, it is more likely that new evidence of the defendant's responsibility would surface than if the defendant is innocent. This is a rough generalization, I know, but I think as a rough generalization is accurate. Moreover, the second point, so my point is, if the defendant is guilty, it is more likely that new evidence of the defendant's responsibility will be discovered than if the defendant is innocent. Because my point is the defendant is indeed guilty, he has committed the crime, therefore I assume that evidence of this person's responsibility would be out there in the majority of cases or in a higher number of cases than if the defendant is innocent. That's my view. Thanks for the probabilistic support. But we can come back to this later. And I'd be very, very happy to have your input on this, seriously. I'm not being, false. I'm really mean it. Because it is something I've been thinking about in the last couple of weeks, but, definitely needs some more thought. So the first point is this generalization. New evidence of the defendant's responsibility is more likely to appear if the defendant is guilty. Second point, if the generalization is accurate and defendants who have been given the intermediate option are aware of it, as I assume they are, because I think that actually this generalization is commonsensical, so we probably all think that it has a kernel of truth. Well, if the defendants are aware of this generalization, then it's likely that the guilty will fear a new trial more than the innocent does. So the intermediate course of action would have a stronger psychological, afflictive impact on the guilty than it would have on the innocent. Putting these points together, I think it's fair to say that the absolutio ab instantia, or something similar to that, would consist in a more severe measure when it is imposed on the guilty than when it is imposed on the innocent. And therefore, it would satisfy the superiority condition as I have proposed it. Now, this is the end of my treatment of that specific question. I would like to say in the last 5-7 minutes something about the last part of the project, because this is even newer than what I just said, and so input on this would be especially valuable. As you will remember, this part is the one where I argue that theories of punishment should concern themselves with the problem of empirical uncertainty, and my final aim is that of showing that under both consequentialist and deontological theories of punishment, the many-valued system or many-valued model gives a superior answer to the question of empirical uncertainty. More specifically, I aim to show that the decision-theoretic justification that I've given to the many-valued system would be viable both under consequentialist and deontological theories of punishment. But of course, the question there is, for it to be viable, we would have to show that both theories of punishment or types of theories of punishment can employ decision theory. And this is something that some of you may frown upon, because decision theory seems to epitomize a classic consequentialist way of reasoning, because after all, it assesses actions exclusively in light of their outcomes or consequences. So this seems to be running against some of the basic principles of deontology, someone could say. So what I would like to do now, in these last 5 minutes, which probably now are 3, is to address the question whether deontological theorists of punishment can avail themselves of decision theory without running into contradiction. Very briefly, although I'm sure that all of you have knowledge of this, let's give rough characterizations of consequentialism and deontological theories of punishment. A consequentialist theory of punishment that says that punishment is justified by appealing exclusively to the possible consequences of punishment. Consequentialists are likely or generally subscribe to the view that we should maximize the good, and therefore punishment is justified if the consequences of punishment justify the good. Deterrence theory is a classic consequentialist theory, insofar as deterrence is understood as an intermediate goal that is itself instrumental to the maximization of the good. So punishment is justified because it produces deterrence, and deterrence in turn is instrumental to the maximization of the good. Okay. Deontological theories of punishment, the classic, I would say, characteristic that defines this theory is that they believe that punishment is not fully justified by the consequences that it might have, but is crucially also justified by reasons that act as trumps with respect to the consequences of punishment. Which means, therefore, that according to deontologists, there are cases where someone is forbidden to punish, forbidden from punishing, notwithstanding that punishment would maximize the good, would produce consequences that maximize the good. Classic example, retributivism. There are different strands of retributivism, but I think the common denominator is that they all believe that there's a rule saying that if the defendant is known to be innocent, then this person should not be punished, no matter what are the consequences of punishing this person. Which means that there will be cases where a defendant who is known to be innocent should not be punished, notwithstanding that punishing this person would maximize the good, or would produce consequences that maximize the good. Okay? Now, I'm not going to be saying anything about the compatibility between consequentialism and deontological theories of punishment. This is not working anymore. I don't know if I touched something, but I'm going to use this. because I think it's something that we can all agree upon. I'm going to say something about the compatibility between decision theory and deontological theories of punishment, okay? My main point, which I expressed like a bit roughly and quickly, is that the essential feature of deontological theories, so the fact that they have these reasons or rules that act as trumps with respect to the reasons represented by the consequences, is a feature that is not operative in context of decision problems under risk or uncertainty rather than knowledge. Okay? Think about retributivism. I think this gives us a good example. So retributivism, as I said, involves this rule saying if you know that the defendant is innocent, you should not punish this person, no matter what the consequences are. Now, think about the decision problem that I've been talking about so far. So the problem not just of setting the standard of proof, but the problem of deciding which verdict system to adopt. Now, the legislator or whatever other authority is answering this question. When this authority answers or addresses the question, certainly the authority has no knowledge about the responsibility of the individuals that are going to be affected by that decision. These individuals are just statistical lives. They're just people that at some point in the future will become involved with the criminal justice system. So if the legislator has no knowledge about the responsibility of these individuals, obviously the retributivist rule against punishing those that are known to be innocent doesn't apply to the legislator, becomes totally irrelevant. So leaves the legislator open to make a choice, whether of the standard of proof or the verdict system, exclusively by relying on the possible consequences of a conviction or an acquittal, which is precisely what decision theory enjoins the legislator to do. Let me point out that when I say that deontological theories of punishment can avail themselves of decision theory, I'm not saying something that is heretical, because at least one deontological theorist of punishment, Alec Wallen, has adopted decision theory. He's a retributivist, and in his paper on the justification of the beyond reasonable doubt standard from a few years ago, he relies on decision theory. I just want to conclude by saying, when I say that deontologists can rely on decision theory, I don't mean to erase all the differences between consequentialism and deontological theories of punishment. I think these differences do exist, but they can be accounted for in the way in which the value function that is required by decision theory to operate is constructed. So these are reasons that are accounted for in the way in which each type of theory assesses the outcomes that will have to be reflected in this value function. And in fact, these differences, in my view, pertain to the kind of reasons that each theory relies upon in the assessment of the value of the outcomes. To give an example, a consequentialist may not treat as reasons things that instead a deontologist may treat as reasons. Classic example could be the idea of dignity or respect, which are crucial to deontological theories of punishment such as von Hirsch's or Duff's, okay? Similarly, a deontologist may treat as reasons things that a consequentialist treats as reasons, but they may give different strengths to these reasons, okay? Another example here could be, again, Duff, when he talks about the 3 R's of punishment: repentance, reconciliation, and reform. Maybe these are reasons for a consequentialist as well. They are valuable consequences of punishing, okay? But probably a consequentialist would not give to this reason as much weight as Duff does. And finally, depending on the theory of punishment, some reasons may be given a higher order than others. Retributivism is likely to give to desert a higher order than other reasons. In other words, other reasons do not count as reasons until desert has been established. This is precisely the main point that Wallen makes in his article. But desert may be a reason for a consequentialist as well, okay? Nothing says that it cannot be. It's just that it wouldn't be given that higher order. So I try to plot the different ways in which we can still account for the differences between these two theories in the way in which we construct the value function that decision theory relies upon, okay? So this is really the conclusion. So if I'm right, and of course I may not be, I often am not, or almost always am not, my justification of the many-valued model can work both under consequentialist and under deontological theories of punishment, and shows that under both types of theories, the many-valued model is a superior way of dealing with empirical uncertainty. Thank you. Thanks for your attention.